Okay, we're going to make a start now. So welcome everyone to our GCSE Maths session. Today's lesson is going to be about similar shapes in terms of volume and surface area. Okay, so we had this starter question on the screen, and this was a slightly difficult question compared to what we've had in previous lessons. It's part of our last topic, but we just didn't get onto it in our last lesson. So it says over here, AOB is a sector of a circle, center O and radius 12 centimeters. The length of the arc AB is 15 centimeters. Find the area of the sector. So the way that you would do this is, first of all, we had two formulas, one to work out the area of a sector and one to work out the arc of a sector. Okay, so let's just remind ourselves of the formulas. The formula for the arc of a sector was angle over 360 multiplied by pi multiplied by the diameter, and this would get you arc length. Okay, so this would give you the length of the arc. This curve that you can see that's 15 centimeters, it would get you that. Okay, now for the area of a sector, the way that you go about that, again, you have your angle over 360 and you multiply by pi and then you multiply by r squared. Okay, pi r squared. And that gives you the area of the sector. Okay, so let's have a look at this one. Okay, and by the way, this is called theta for anyone that doesn't know. This is theta, and all this means is angle. Okay, angle that we don't know. Okay, so it says we need to work out the area of a sector. And if we look at what this question is asking for, we need to work out the area of a sector. Now, in terms of working out the area of a sector, we need to know the angle. However, in this case, we don't know what this angle is. Because we don't know what the angle is, it's going to be very difficult for us to work out what the area of this sector is. Okay, so we need to work out that angle first. Okay, now we're given what the arc length is. We know what the length of the arc is. It's 15 centimeters. So if we use this first formula over here, we don't know the angle, so we're just going to say theta because we don't know the angle, and that's over 360, and then we're going to multiply by pi, and then we're going to multiply by the diameter. Now we know that the radius is 12 centimeters, so the diameter is just going to be 2 times the radius, so it's going to be 24 centimeters. That's what the diameter is going to be. Okay, so the diameter is going to be 24 centimeters. It's double the radius. And we know that that is going to be equal to the length of the arc. Okay, and the length of the arc is 15 centimeters. That's what we've been given in this question. The title of today's lesson is Similar Shapes, Volume and Surface Area. Similar shapes, volume and surface area. Okay, so again, if you have a look over here, this is equal to 15 centimeters. Okay, that's what the arc length is equal to. So if we rearrange this, we can divide by 24 and we can divide by pi. So we get pi over 360, sorry, theta over 360, and that's equal to 15 divided by 24. We want to get this theta. This theta is like an x. Yeah, we want to get it by itself. So we're going to divide by 24 on both sides, and we're going to divide by pi on both sides to get rid of the multiply by pi and the multiply by 24. So we're going to have 15 over 24 pi. Because 24 multiplied by pi is just 24 pi. And then we're going to get rid of it by dividing by 24 pi. And then to get theta by itself, this circle thing that you have over here, that's just an x. We're just going to get rid of this 360 by multiplying by 360 to the other side. So we're left with just theta on that side. That's the angle. And that's going to be equal to 15 over 24 pi multiplied by 360. Okay, so this is what you can just type into your calculator and you would get what the angle is. Okay, so I'm just going to type in what that is. So 15 over 24 pi, and then we're going to multiply it by 360. Okay, and that's going to get us 71.62 degrees. Yeah, this is part of last week. So if you weren't here last week, then you'll have to watch the recording again because this is a hard question from what we did last week. So we would get 71.62 degrees. Okay, that's what the angle over here is, 71.62 degrees. And now we can work out the area by using this formula. Okay, and the area is the angle, which is 71.62, divided by 360, multiplied by pi, and then multiplied by r squared. Now, r is 12, as you can see over here. So it's going to be 12 squared. And then if we type that into our calculator, we are going to get an answer of 90. Bang on 90. So the area of the sector is 90 centimeters squared. Okay, so that was a difficult question. It's one of the more difficult ones from our last topic. But the way that we've worked this out is by using this formula. This is the formula to working out the arc of a circle, of a sector. So remember, the arc is just this curved part of a sector. That's the formula that you would use. And to work out the area of that sector, this is the formula that you would use. Okay, and theta just means x. Okay, it's just a way of representing an angle. Okay, now because in this question we weren't given what the angle was, as you can see, we didn't know what the angle was, we needed to work out the angle. So because we knew what this arc length was, that was 15, we used this formula of arc length and we needed to work out the angle. So this is our x, this is what we need to work out. And that's over 360. We're multiplying by pi, we're multiplying by 24, and we know that's equal to the arc length, which in this question is 15. That's the length of that curved part. And then all we did was we rearranged it to get theta, the subject of the formula. So we wanted it by itself, so we divided by 24 to move the 24 on the other side. We divided by pi to move the pi on the other side. And we got theta over 360, and that was equal to 15 over 24 pi. And we wanted this theta to be by itself because remember this theta is like an x. So we got rid of the divide by 36 and we multiplied by 360, sorry. So we moved the 360 to the other side and we got theta is equal to 15 over 24 pi multiplied by 360. Okay, and this is what we've just typed into our calculator, and we got this our answer, 71.62. That's what this angle of the sector is, 71.62. Now it says work out the area of the sector. So now we've worked out the angle, we can use this formula over here to work out what the area of the sector would be. So it would be 71.62. That's what our angle is that we've just worked out over here. So 71.62, and that's over 360. Then you multiply it by pi, and then you multiply it by the radius squared. And we know that the radius is 12 centimeters as given in the question. And then if you type that into your calculator, you get a good answer of 90 centimeters squared, and that's what the area of the sector would be. Okay, so that's a continuation from our last lesson, just as a recap question from what we did in our last lesson. Okay, now what we're going to do is we're going to move on to today's topic, where we're going to be looking at surface area and volume, but with similar shapes. Okay, and this is a very common exam question. It's for those doing higher papers. Okay, so there's a simple method to go about this. Okay, and we're going to go through that simple method, and I'm going to run through an example of how to actually work it out. Okay, and then I'll give you some questions for you to have a go at. So the method is you draw out a table. So firstly, what are we expecting? basically what you're going to get is you might get a small cone like this, and then you might get a big cone like this. Yeah, these two shapes are similar. When you have the same shape, so a cone and a cone, it's the same exact shape. However, you have different sizes. That means the two shapes are similar. When I wrote 90 centimeters squared, that's the area of the sector. That's the area of this thing over here. Okay. So over here, we're talking about similar shapes. Similar shapes are basically 3D shapes which are the same shape, however, they're different sizes. That's what a similar shape is. So if you had a cone and a cylinder, they're not similar shapes because they're different shapes. They're two different shapes. Over here, we have a smaller cone and then we have a bigger cone. So these two shapes are similar. And what you could be asked to do is you could be given the volume of this cone over here, and then you could be asked, using the volume of this cone, I want you to work out the volume of this cone, this bigger cone. Okay, and there's a method of doing that. You could be given the surface area of this cone, and then you could be asked to work out the surface area of what the bigger cone is. You could be given the radius of this cone, and then you could be asked to work out what the radius of the bigger cone is. Okay, so that's what to expect with similar shapes in terms of surface area and volume. Okay, and there's a simple method to go about this, and that's what we're going to go through. You're going to normally be given two shapes, and then you're going to be asked to work out the surface area of one shape using the surface area of the other shape. Work out the length of one shape using the length of another shape. Working out the volume of one shape using the volume of another shape. Okay, and these are the steps that you would go through over here. And this won't really make sense at the moment. It'll make sense when we look at an example. So the first thing that you would do is draw out a table. The columns should be labeled with A and B, and the rows should be labeled with length, surface area, and volume. Okay, so if I was to just draw out a sketch of that table will look like this. You would have shape A, and then you would have shape B. Okay, that's your column. And then you would have length, you would have surface area, and you would have volume. Okay, so that's why you would label it like that. Okay, so with a question like this, you would draw out a table like that. You would have shape A and you would have shape B in columns. And then on your rows, you will have length, surface area, and volume. And ultimately, when you know the surface area of one shape, you can work out the surface area of the other shape. When you know the volume of one shape, you can work out the volume of the other shape, and so on. Okay, so you draw out this table. First, with a question like this, you draw out that table, and it will make life much more easier. Then you work out the scale factor. Now, what the scale factor means, it's like a multiple. How can you get from one number to another number? So if I told you that the length of one shape is 5 and the length of another shape is 10, then the scale factor would be times 2. That's what the scale factor would be. If the length of one shape was 10 and the length of another shape was 30, then the scale factor would be 3. Because to get from one shape to another shape, you're going to have to multiply by 3. Okay, so that's what you do second. You work out what the scale factor is. Now, the third step is that how can you work out the surface area and how you can work out the volume. To work out the surface area, all you have to do, so you know that this is your scale factor in this case. Let's say that the surface area is 7 and the volume is 10, okay, of shape A. To work out the surface area of shape B, all you are going to do is you're going to square the scale factor. So you know that the scale factor is 2 in this case, as you can see, because 5 to get to 10, you multiply by 2. To get the surface area, you have to multiply by the scale factor squared. So you have to multiply by the scale factor, which is times 2, and you square it. So you're basically multiplying by 4 instead. Okay, so that's what this states over here. The surface area of the smaller shape to the surface area of the bigger shape, you multiply by the scale factor squared. So you get your scale factor, and then you square that number to get your surface area of shape B. So 7 times 2 squared, 7 times 4 gives you 28. So the surface area of shape B would be 28. Okay. And for the volume, it's very similar as well. However, you multiply by the scale factor, which is 2, and this time not squared, you cube it. You multiply by the scale factor cubed. So you do 10 times 2 cubed. 2 cubed is 8, so you do 10 multiplied by 8, and that gives you 80 for the volume of shape B. And that's how you go about this. Okay, you draw out your table first: length, surface area, volume, and then shape A and shape B. When you're going from the length of the smaller shape, let's say that shape A is the smaller shape, as you can see, you work out what the scale factor is. Yeah, you work out what the scale factor is. Yeah, I can give you time to note this down if you want to. I'll talk through it like this. So the scale factor is basically how you get from the smaller shape to the bigger shape, or how you get from shape A to shape B. That's what your scale factor is, what you need to multiply by. Okay, and that would be your length scale factor. Your surface area, to get from the surface area from one shape to another, you have to multiply by the scale factor, but this time it would be squared. Okay, you multiply by the scale factor squared. Okay, because if you think about it, surface area has the volume like centimeters squared. Because there's a square there, that's why you're multiplying by the scale factor squared. Okay, and volume, you multiply by the scale factor cubed. Okay, so for example, volume has units centimeters cubed. Okay, because it's centimeters cubed, you multiply by the scale factor cubed. Okay, and you only multiply when you're going in one direction. So if you're going from left to right, you multiply. If, for example, you had a gap in one of them, okay, let's make a gap in one of them. Let's pretend that we didn't know this over here. Yeah, the method that this is for will make sense when we look at the question. So hold that thought. We'll come back to the question. So let's say that we didn't know what the surface area of shape A is. We're going the other way. When we're going the other way, we don't multiply, we divide. So we would divide by 2 squared. That's how we would get from the surface area of shape B to the surface area from shape A, to shape A. When we're going from left to right, we're multiplying. When we're going in the opposite direction, we're dividing. Okay. So now what we're going to do is we're going to look at an example. Okay, and this will make more sense when we look at an example. This is just the method that you would follow. What is it called when the small shape is the same volume as the big shape? Um, when the small this will make more sense when we come on to a question, but I don't think you can have the same volume. And um if you have the same volume of the small shape and the big shape, then that means that the shapes are identical. They're not really similar, they're identical shapes. Okay, so if we look at this example over here, this is the example that we're looking at. So it says, this is an example of what you could get in an exam. It's a realistic example of what you could get in an exam. And I'll show you how the method works. So it says two solid shapes, A and B, are mathematically similar. The base of A is a circle with the radius 4 centimeters. The base of shape B is a circle with a radius of 8 centimeters. The surface area of shape A is 80 centimeters squared. Work out the surface area of shape B. So step one, draw your table. So what we're going to do is we're going to have A and B, okay, in a column like that. Then we're going to add in length. We're going to add in surface area, and we're going to add in volume. Okay, so we've added in a table there. That's first step. Now we're going to fill in the information that we know. So we know that the base of shape A is a circle with the radius of 4 centimeters. So this is the length. When it's talking about radius, that's always the length. So shape A has a length of 4 centimeters. So we're just going to write in 4 there. Okay. The base of shape B is a circle with the radius 8 centimeters. Okay, so we're going to write down 8 over here. It says the surface area of shape A is 80 centimeters squared. Okay, so we're going to write down 80 over here. We need to work out what this surface area over here is. Okay, so how do we do this? Yeah, so step one, we work out the scale factor. Okay, so if we work out the scale factor, to get from A to B, what do we need to do? We need to multiply by 2. Okay, so that means when we're working out the surface area, we need to multiply by 2 squared, and when we're working out the volume, we need to multiply by 2 cubed. Okay, so to go from here to here, from surface area of A to surface area of B, you're going to have to multiply by the scale factor, which is 2, but 2 squared. Okay, so we would do 80 multiplied by 2 squared. So it's going to be 80 multiplied by 4, and that's 320 centimeters squared. Okay, so the answer to this is just 320 centimeters squared. Okay. Now it says for the next question, the volume of shape B is 600 centimeters cubed. Okay, so let's fill that into our table. The volume of shape B is 600 centimeters cubed. And we need to work out what the volume of shape A is. Okay, so this time we are going this way. We're going in the opposite direction. We know that if we were going this way, then we would multiply by the scale factor, which is multiplied by 2, and then we would cube it. So we're basically multiplying by A. But because we're going the other way, we're not going to multiply, we're going to divide by 2 cubed. Okay, and 2 cubed is 8. So we basically just have to do 600 divided by 8. Okay, so 600 divided by 8. Okay, and 600 divided by A gives you an answer of 75. So the volume of shape A is going to be 75 centimeters cubed. Okay, that's what you would have for your final answer. 75 centimeters cubed. Okay, so as you can see, if you draw out your table, it's going to just make life much easier. If you're going from left to right, you're multiplying. If you're going from right to left, you are dividing. Okay, and remember, you work out your scale factor of length first, and then you work out the scale factor of volume, and then you work out the scale factor, the surface area, and then the volume. Okay, now sometimes you might not be given what the length is. Okay, if you're not given the length, you might be given the surface area. If you're given the surface area, Okay, let's say that let's say we draw a quick table over here, AB. Okay, we've got this, and we've got length, we've got surface area, and we've got volume. And let's say we were given this is 10, and this is 20, and this is 5. Okay, and we didn't know what this length was. Okay, now we know to get from 20 to 5, we need to divide by 4. Okay, and we know that this has been squared, the scale factor has been squared to get divided by 4. So to go from here to here, 10 to get to the question mark, we're going to have to divide by the square root of 4. Okay, we're going to find the square root of 4 to work out what the original length was. Okay, and the square root of 4 was 2. So we would just divide by 2, and that would get us 5. And if you went around and did this again, 5 to get to 10, you multiply by 2. 5 to get to 20, you multiply by 2 squared, which is 4. So 5 times 4 is 20. Okay, so that makes sense over there. That shows that it's correct. So for surface area, we're dividing by 4, going right to left. So that means we need to, going from B to A in terms of length, we're going to divide by the square root of 4. Okay, that's what's going to give us what our scale factor is. Okay, because remember, to get the scale factor of surface area, you square your scale factor of length. Okay, and to get your scale factor of volume, you cube your scale factor of length. So to get your scale factor from the scale factor of surface area, you square root. To get your scale factor from the scale factor of volume, you cube root. Okay, and this will make more sense again when we look at some more example questions. Okay. We'll have a go at this question over here first. So I want you guys to have a go at this question. Have a go at it, type your answer into the chat once you're into the Q&A once you've got an answer, and then we'll go through it. If you're struggling, do let me know, and we'll go through anyway at the end, after 2 minutes. Okay, I'm just going to give you guys 1 more minute before I start going through the answers. So this question would be around, I think maybe 2 or 3 marks. And this question would probably be at around grade 7 mark question. Okay, so I'm going to start going through the answers now. So again, with this question, we're going to draw out a table. So we're going to say shape A, and we're going to say shape B, and we're going to say length, we're going to say surface area, and we're going to say volume. Okay, so we've drawn out our table. Now, we know some key features. We know that the length of shape A is 4 centimeters. We've got 4 there. And we know that the length of shape B is 6 centimeters. So we know 6 is there. We know that the volume of cylinder A is 80 centimeters cubed. So 80 centimeters cubed is the volume of shape A. And we need to work out what the volume of cylinder B is. So that's our question mark there. So step 1, work out your scale factor. So how can we get from 4 to 6? Okay, so if you use a calculator, to get from 4 to 6, you need to multiply by 1.5. Okay, so you're multiplying by 1.5 to get from 4 to 6. Okay, so that means to work out what the volume scale factor is, you're also going to multiply by 1.5. However, because it's volume, you're going to cube that. You're going to multiply by 1.5 cubed. Okay, so we're going to do 80 multiplied by 1.5 cubed, and that's going to get us an answer of 270. Okay, so our answer there is 270 centimeters cubed. Okay, so 270 centimeters cubed. That's how you would work out. Again, as you can see, drawing the table out makes life much easier. Okay, so have a go at this one now. Okay, so this is slightly different. You're not given the shapes drawn out for you. Okay, and this would probably be worth more marks as well. And it's slightly more difficult. But again, draw out your table, see what you can fill out, and then you can go from there. Okay, just one more minute, and then I'm going to start going through the answers. Okay, we're going to start going through the answers now. So this was a slightly more difficult question. It says X and Y are two geometrically similar solids. So what we're going to do is we're going to draw out a table. Okay, so we're going to have shape X and we're going to have shape Y, just like that. And we're going to have length, we're going to have surface area, and we're going to have volume. Okay, so we've made our table. Okay, now let's fill in what we have. So it says the total surface area of shape X is 450. So this is 450. The total surface area of shape Y is 800. So this is 800. The volume of X is 1350. We need to work out what the volume of Y is. Okay, so this is a question mark. Now the way to work this out, this time we're not given the lengths, so we can't work out the scale factor. Okay, however, we are given the surface areas, so we can work out what this is over here. 450 to get to 800. So 800 divided by 450 gives you 16 over 9. So to get from 450 to 800, you need to multiply by 16 over 9. Okay, because if you type into your calculator 800 divided by 450, you get 16 over 9. So to get from 450 to 800, you're going to multiply by 16 over 9. Now, if we know the scale factor for surface area, so we know the scale factor of surface area, we can work out what the true scale factor is. Okay, because we know to get the scale factor of surface area, you need to square your answer. So to get this normal scale factor, you have to square root the scale factor of surface area. So you need to find the square root of 16 over 9. Because when we're working out the scale factor of surface area, you multiply by the square of the scale factor. You square the scale factor. So if you need to work out the scale factor, the normal scale factor, you need to square root the surface area scale factor. So you work out the square root of 16 over 9, and that gives you 4 over 3. So this is the normal scale factor. Going from here to here, you just need to multiply by 4 over 3. Okay? You just need to multiply by 4 over 3. That's it to get from one side to another. So now, to go from here to here, you need to multiply by the scale factor, which is 4 over 3. But this time you cube it because it's volume. So you multiply by 4 over 3 cubed. So you have 4 over 3 cubed, and then you multiply it by 1350, and that's going to get you an answer of 3200. All we have done is we've done 1350 multiplied by 4 over 3 cubed, and that got us 3200. Okay, so again, as you can see, drawing out that table makes life much easier. If you know the scale factor of surface area, you can work out what the scale factor of length is by square rooting it. If you know the scale factor of volume, you can work out what the scale factor of length is by cube rooting it. Okay. Just see. So we'll have a go at this one now. Okay, so again, 2 minutes, have a go at it, and then we'll go through the answers. Okay, this would be worth 3 marks. Yeah, we will be doing a book look here after this question. Okay, just one more minute and then I'm going to start going through the answers. So this is similar from our last question that we just did. Okay, so I'm going to start going through the answers now. Okay, so working on the height of the cone. So again, we're going to draw out our table. So we have P, and then we have Q, okay? And then we're going to draw out our columns, and we're going to have length, we're going to have surface area, and then we're going to have volume. Okay, so we've drawn out our table. Now we know that the surface area of P is 24. So we're going to write down 24 there. We know that the surface area of Q is 96. So we're going to write down 96 there. We know that the height of P is 4. So that's the length. That's 4. And we need to work out what the height of cone Q is. Okay, so this is what we need to work out. Now there is a row where we know both numbers. So 24 to 96. How do we get from 24 to 96? If you type that into your calculator, we need to multiply by 4. That's how we get from 24 to 96. We multiply by 4. Okay, so that means that the scale factor of surface area is 4. We need to work out what the scale factor, the normal scale factor is. To work out the normal scale factor, you have to square root the scale factor of surface area. So the square root of 4 is just 2. So all you're going to do here is you're going to multiply by 2. Okay, and 4 times 2 gives you 8. So 8 centimeters is what your final answer would be.